Threeey Atlas is not a comet, it's a Jupiter probe. Copy that, stand by, we lost the tail, object just corrected. The radio goes quiet as the NASA tracker freezes on a clean arc kinked right at Jupiter's magnetosphere. Then a whisper, that correction wasn't gravity. On screen a label, Threeey Atlas, the third interstellar visitor after Oumuamua and 2/Borisov. But here's the claim, this isn't a comet. It's an active Jupiter probe with roots in older technology than we want to admit. If it's controlled, someone's mapping our gas giant. We've got files, logs, magnetosphere anomalies, and an echo in the Voyager record. To see why that matters, go back before discovery. The discovery and the first oddities. It started with a brightness curve that wouldn't sit still. Early detection teams stitched together survey frames and kept getting a light curve that pulsed like a heartbeat, regular, then flattened, then regular again. Comets don't do tidy rhythms on command. The first notes tagged it as calibration error. A second pass said atmospheric seeing. A third flagged non-cometary outgassing claims as outliers, but the photometry never married the spectra. The colors whispered dust, the lines didn't show the usual volatile fingerprints. One instrument team circled an asymmetric coma that refused to line up with solar heating models. The explanation shifted each night, the asymmetry stayed. Hear what nod at people who stare at plots for a living. The reported coma looked like a veil hung to one side, then vanished, then reappeared offset again, like a controlled plume, not a melting snowball. Spectrographs expected the usual water and co-signatures flaring with distance to the sun. Instead, detections came and went in a way that mapped better to orientation than temperature. And every time someone said outgassing, someone else pointed to the lack of a thermal bump where it should be. Timing made it stranger. There was a suspected course shift near a geometry window that put Jupiter's Lagrange points in the right places for a subtle assist. On paper, it could be coincidence. In the logs, the residuals tightened right as that window opened, tiny nudges that pulled the track toward the magnetosphere's flank. The orbit fitters adjusted parameters, the fit improved, and the footnotes grew cautious. Non-gravitational acceleration cannot be excluded. Meanwhile, older Jupiter anomalies, boring to most, gold to a few, woke up in backchannel threads. An archive memo about phantom command chirps during a past flyby resurfaced, tossed into a private email list with a one-line shrug, probably unrelated but weird timing. No one wanted to be the person who said the quiet part first. The micro-story that captures the mood is a margin scrawl. An amateur, retired engineer, meticulous observer, printed the plot, drew a tiny arrow at the bend, and wrote, "It's breaking." His daughter photographed the scribble beside a coffee ring and posted it to a forum. Professionals hate that kind of thing. They also saved the file. Stakes started to crystallize. If the non-gravitational acceleration wasn't sublimation, a comet venting in random fits, but thrust, even minuscule thrust, it implied intent. A sail catches sunlight. Panel vents ions. Either way, someone or something set it up to react, to steer. That changes the whole frame. A rock is a passenger, a probe is a pilot. Photometry teams and spectrograph folks argued without calling it an argument. One slide deck showed harmonics in the light curve, the kind you see when flat facets catch light, then slip into shadow with a predictable cadence. Another countered with coma asymmetry models that can fake harmonics under uneven outgassing. The words got careful, non-diagnostic, consistent with, intention with. Reputations live or die on the difference between anomaly and artifact. Then the timing flagged people who watch Jupiter for sport. The suspected course tweak synced with a reconnection event in Jupiter's magnetotail, a time when field lines snap and rejoin, slinging charged particles like a whip. If you wanted to ride a field, that's when you do it. If you were just melting, you wouldn't care. While that debate simmered, a small observatory reported a curious quieting of the tail. Coma collapsed just as a separate radio dish logged a narrowband ping during a Jovian alignment. The teams didn't talk, their logs did. The timestamps matched within minutes. The dish operator wrote artifact on his sheet and moved on. The observer knocked her mug over when the live tracker drew with a sharper arc and a cleaner centroid. She wiped the desk, saved the plot, and kept her mouth shut. You could feel the institutional language tighten. Writers used cometary candidate more often. Press offices trimmed phrasing from unexpected to non-repeatable. A preprint that used the word acceleration in its figure caption reappeared with the figure unchanged and the caption softened to residuals. That's risk management. It's also a tell. Meanwhile, something else was happening in quiet Slack channels. People began bookmarking old Jupiter papers that most of us never read twice. Magnetometer spikes during flybys with no clean source. A mapped hiss, literally Jovian hiss, with frequencies that liked certain geometries. Declassified telemetry gaps right at high-intensity passes. Nothing you could hang a headline on. Everything you would keep if you thought a vehicle might use the planet's electromagnetic muscle as both engine and wire. The amateurs kept pace. One grad student flagged a periodic glint at the edge of the photometry noise floor and got told to rebin average it away. She did then save the unbinned file under a bland name. A senior observer posted a gentle reminder about confirmation bias. Another posted the classic, extraordinary claims, extraordinary evidence. A third DM'd a location and time for the next clear night window, adding, bring the fast camera. What nobody knew at the time, because you can't know it until you line the layers up, was that the oddities predated the official discovery. A reprocessed survey sweep, stitched weeks later, showed a faint, regular flicker with the same period the grad student had found. The object was already strobing. We just weren't looking for a strobe. To understand why the weirdness mattered, you step back from the frames and listen to the cadence. A natural body argues with you in thermal curves and dust plumes. This one negotiated with geometry and timing. It hugged Lagrange windows. It quieted its tail when a dish heard a whisper. It leaned toward the magnetotail when reconnection spiked. That's not random, that's behavior. The weirdness started before telescopes found it. And once you see that, you start asking an uncomfortable question. Who is steering and why Jupiter? Oumuamua, Borisov, and the Interstellar baseline. To understand what Threeey Atlas is doing, you need a baseline. Oumuamua said it, Borisov framed it. In 2017, Oumuamua came through like a splinter of night, no coma, no steady outgassing, a light curve that swung wildly as if a flat object was tumbling, and a small but persistent non-gravitational acceleration that didn't match the usual Comet playbook. The explanations piled up, hydrogen ice sublimating invisibly, a dust mantle venting in odd ways, even a thin light sail catching solar pressure. The safest word was outgassing. It showed up in papers like a seatbelt, cautious, familiar, non-committal. Then 2I/Borisov arrived in 2019 and behaved like a comet from a training manual. It sprouted a clear coma, put out the right volatile signatures, and followed a path gravity could explain. If you wanted a control sample for interstellar visitors, Borisov gave it. You could point to its tail, compare spectra, and say, that's natural. Suddenly we had a 1-2, one outlier that looked spacecraft-like if you squinted, one natural that didn't ask you to squint at all. Here's where the institutional language gets interesting. With Oumuamua you saw hedging, consistent with outgassing, non-diagnostic acceleration, unusual but not unprecedented. Nobody wanted to leap on a career-altering claim. You could feel the reputational gravity in every abstract, explain it with the least risky mechanism, even if the model had to stretch. The hydrogen ice hypothesis tried to thread that needle and snapped under its own constraints. The light sail idea kept buzzing at the edge, too bold for some, too tidy for others. Shape and spin made it worse. The light curve implied extreme elongation or a flattened shard, and the rotation looked like a tumble that should have smeared out any directed outgassing. If jets were doing the pushing, their distribution had to be just so to avoid flipping the body into chaos. If sunlight was doing it, the area-to-mass ratio had to be high, like a plate. Every fix created a new headache. Meanwhile, observers noted that the acceleration scaled with distance from the sun in a way that felt like radiation pressure, not sublimation. Borisov, by contrast, quieted nerves, gave everyone a place to stand. Interstellar objects can be normal. When Threeey Atlas appeared, that precedent mattered. You could hold up Borisov and say, this is what we expect. And then you could look at Threeey Atlas's behavior, its light curve harmonics hinting at flat facets, its inconsistent volatiles, its tailored coma, and see echoes of Oumuamua instead. Same rhyme, different verse. The sails versus jets debate never went away, it just evolved. For Oumuamua, sails implied manufacture. For Threeey Atlas, jets implied intent if they didn't map to temperature. Teams tried to normalize the language again. Non-gravitational acceleration may result from anisotropic mass loss. It's careful, it keeps the conversation inside the building, but the data kept tugging. When modulation in brightness lines up with plausible orientation changes rather than simple heating, you're not just measuring chemistry, you're watching someone manage a cross-section. Mutation risk shaped how these stories were told. They replaced impossible with unlikely. They leaned on instrumental systematics until independent sites reproduced the same oddities. Press offices amplified safe phrases, candidate Comet, preliminary, under review. It wasn't a cover-up so much as institutional muscle memory, and yet the baseline had shifted. Oumuamua had made artificial a permissible word to whisper, even if you couched it as a technology scenario. Now pull that thread into Jupiter's neighborhood. Oumuamua never flirted with a magnetosphere. It used the sun's field and left. Borisov shed gas like a regular traveler and moved on. Threeey Atlas, though, started to echo the first outlier, light, orientation, acceleration, while drifting toward the largest electromagnetic structure in the solar system. If you accept that Oumuamua's push might have come from sunlight acting on a high area-to-mass body, Then imagine a cousin tuned not just for light, but for fields, writing gradients, timing nudges to reconnection events. Suddenly, outgassing feels like the wrong grammar for the sentence you're reading. What nobody said out loud in the early memos was the obvious: precedent shapes interpretation. With one clean natural and one nagging outlier, the third object forces a choice. If it behaves like Borisov, case closed. If it hums in tune with Oumuamua, you have a pattern: interstellar visitors that aren't random rocks but engineered flyers sampling or exploiting our backyard's physics. Meanwhile, Jupiter holds its own file of strangeness. Radio storms tied to Io's circuit, hiss and chorus emissions that light up along predictable lines, magnetometer flickers when spacecraft cross the current sheet. Put the baseline next to that environment and you get a question you can't soften with euphemisms. If some interstellar objects behave like craft and the biggest dynamo in the neighborhood is Jupiter, what's likely to happen when one meets the other? While that was happening on paper, the sky kept answering with the same rhythm. Borisov for normal, Oumuamua for strange, and Threeey Atlas rhyming with strange while leaning hard toward the gas giant's domain. That's your baseline. Now watch what Jupiter does to it. The Jupiter Magnetosphere files. Jupiter's magnetosphere isn't just big, it's a world within a world. Start with the Io flux tube, a literal electric circuit linking Io to Jupiter's poles. When Io moves through the magnetic field, it drives currents that light up radio emissions. Observers who track the decometric bands know this: certain longitudes, certain geometries, and the planet starts to sing. Those emissions spike when the flux tube aligns, like a lighthouse beam sweeping over a sensor. Now match that with old flyby logs. During those alignments, magnetometers on passing craft saw sharp spikes, clean, narrow features layered over the rolling background of Jupiter's field. Meanwhile, something else was happening in the background noise. Jovian hiss, that's the term, fills parts of the spectrum, a whispery, structure-rich sound that maps to plasma waves. Teams mapped the hiss, cataloged chorus emissions, and plotted how they clustered near the current sheet and in the plasma torus fed by Io's volcanoes. They could explain a lot. What they couldn't explain were the moments when the hiss seemed to carry patterned steps, as if a carrier wave was climbing a ladder. Engineer logs from one mission called them phantom signals because they mimicked command chirps without matching any known format. The official explanation stayed conservative: unknown plasma interaction. The off-record note added: very regular. Those logs sit next to declassified telemetry gaps. During high-intensity passes, when fields rotated fastest and particle densities peaked, downlink streams occasionally went thin like a breath held. You could chalk it up to simple link stress, but the timing often nailed the most energetic rotations, and once a gap ended with a burst of packets that looked like a re-handshake. A console tech, long retired, wrote years later about a day they thought they'd lost lock, only to get it back with a configuration they hadn't initiated. He remembered it because the console printed a timestamp twice, as if two clocks had argued. If the magnetosphere is a chaos of fields, it's also a medium. That's the hypothesis that kept resurfacing. The system's electromagnetic muscle isn't just an obstacle, it's an engine and a wire. Charged dust and ions ride field lines, waves carry energy and potentially information. Spacecraft already tap into bits of this. We measure, we damp, we sometimes surf small variations without intent. Now flip the perspective. If a craft were designed to interact with those fields, it could use Lorentz forces for drag or lift, bleed momentum by spitting out ions in phase with the field, and mask its power signature by blending with natural emissions. You don't light a rocket when the planet will push and pull for free. Historical anomalies look different under that light. During the Voyager era, radio scientists logged decometric storms tied to Io's position so well they could forecast them. Hidden in those plots are side lobes, tiny repeated off-angle features that repeat at offsets inconsistent with known beaming patterns. They might be instrumental ghosts, or they might be a byproduct of something riding the same circuit, stepping its frequency in time with the main beam. Later, during Galileo and Juno, magnetometers recorded brief, needle-like spikes right as the spacecraft crossed the current sheet. Papers wrote those up as non-repeatable transients. The shape of those needles, though fast rise, disciplined decay, looked engineered to anyone who's debugged a power system. Tie that to the phantom chirps. One engineer's lab notebook described a chirp ladder, discrete tones stepping up and down in a pattern that resembled a handshake attempt: ping, wait, confirm, escalate, repeat. The frequencies weren't in the craft's standard table. They synced in one case with an IO alignment window. The team tested every interference scenario: Earth sources, onboard harmonics, even weird multipath effects from the spacecraft's body. Nothing fit cleanly. The final line in the report read, "Unresolved, no operational impact." That means file it and move on. It also means the pattern never sat right. Declassified bits add texture. On one high-intensity pass, the ground received what looked like a valid command echo. The checksum failed, but the timing matched the cadence of a recent uplink. The team treated it like a glitch because you have to, but a private memo compared its spacing to known Jovian chorus elements. If a probe were leveraging the magnetosphere as a comms channel, it might encode over or within existing emissions, piggybacking on noise that's always there. That's not science fiction. We hide communications in noise floors all the time. Now fold in energy. Jupiter's magnetosphere is the biggest electromagnetic engine in the solar system. The plasma torus, the reconnection events in the magnetotail, the rotating fields, there's free energy everywhere if you have the hardware to take it. A craft designed to parasitize those changes could brake, steer, and charge without leaving a hot chemical fingerprint. It would time maneuvers to reconnection spikes, lean into flux tube alignments to boost comms throughput, and ride the current sheet like a river barge centering in a channel. What nobody knew at the time, reading those old files, was how they'd feel when a new object slid into frame and started behaving like it knew the rules. The hiss maps, the magnetometer needles, the phantom chirps, the telemetry gaps during peak rotations, they read like a training manual once you allow one premise. The magnetosphere isn't just weather, it's a usable field. If that's the engine, the next question writes itself. If the system can push and carry a craft, who built the vehicle that knows how to use it? Ancient tech threads, myths, geometry, and orbits. Get this, the oldest star maps don't just tell stories, they draw flight plans. Start with the sky gods. Across Mesopotamia, Jupiter wasn't a vague light, it was Marduk, the king planet that set order. Priests tracked its wandering path with clay tablet ephemerides fine enough to forecast retrogrades. In Greece, Zeus ruled from the same bright point, while in Rome, Jupiter Optimus Maximus got temples where priests could time rituals to its synodic beat. These weren't random devotions. They were attention paid to a clock. Now lay geometry over faith. Sacred layouts from temples in Babylon to sanctuaries in Latium embed ratios that match orbital resonances, 2:1, 3:2, the same simple fractions that lock moons like Io, Europa, and Ganymede into a metronome. You see triangles and hexagons in floor plans that echo Lagrange stability, the places where gravity balances into wells and peaks. It sounds poetic until you overlay actual sky positions from the epochs those buildings went up. Angles line with Jupiter's stations. Courtyards face mornings when the planet rises near key stars used for timing. Architects pulled meaning from math, and their math hugged the same structures a navigator would use. Archaeoastronomy fills in the spine, alignments that look ceremonial double as calibration marks. Temple's axis catches first light when Jupiter sits near opposition. The secondary door frames the planet's heliacal rising after conjunction. Repeatable, countable events. Priests recorded omens, sure, but they also held tables, lists of when this wandering star would sit in which part of the sky and how long until it returned. You can imagine a human figure on a roof, not praying, counting. Then there are inscriptions that make people squirm because they sound like they know too much. Fragments refer to listeners at the storm's edge, words that scholars file under metaphor for priests at thresholds between worlds. But if you've mapped the Great Red Spot's persistence, storm's edge isn't just myth. It's a stable marker on a rotating body, a feature you could use to phase-lock timing. Texts talk about the ear of the god opening at intervals. Put that beside Jupiter's radio storms tied to Io's circuit, and opening becomes a predictable alignment that makes the planet audibly loud. Nobody knew at the time, because they weren't looking for it, was that some of those omens correlate with cycles we now measure in the magnetosphere. The cadence of recorded portents clusters around synodic periods when Jupiter sits in positions that maximize visibility and coincidentally maximize radioactivity tied to Io. You don't need antennas to know when a beacon is strongest, you need a habit of watching. Myths can wrap a practice that's practical. Point your eyes when the window opens. Here S where geometry leaves the ground. The 5 Lagrange points of a two-body system, say the Sun and Jupiter, are not trivial to find without calculus. But the sky gives you hints if you're patient. Trojan swarms sit near L4 and L5, 60 degrees ahead and behind Jupiter. Ancient texts personify attendants that go with the king, arriving before, departing after. That's a story about timing waves, phased companions stationary in a co-rotating frame. Carve that into stone long enough and you teach a pattern. Some places move with the god. Frame the past not as superstition, but as a user manual disguised for memory. If a taught system existed, rituals as mnemonics, buildings as instruments, it can be reactivated simply by reading it as engineering. Set your watch by synodic cycles. Use opposition as your bright calibration. Watch for the planet's voice when alignments light the decometric bands. Mark the fixed storm as a surface clock. Keep the Lagrange attendants in your mental model of safe harbors. It's a language for navigation hidden in plain sight. Meanwhile, something else was happening across cultures that never met. The Maya tracked Venus with brutal precision, but their Jupiter notes code intervals that match conjunction cycles with Saturn, grand conjunctions that reset long calendars. In Vedic texts, Brihaspati, Jupiter governs wisdom and cycles that rule when to begin journeys. If you strip the poetry, you're left with a network of watchers' timing starts to stable windows. Skeptics will say metaphor stacks on coincidence, and a lot of it does, but then you hit that one inscription that doesn't behave like literature. A fragment lists nights when the year opens, offset by consistent counts that match Io's orbital period scaled into a ritual week. Another text ties offerings to the storm that never dies, a phrase we can ground in a spot that predates telescopes but has been seen for centuries as a peculiar blemish. The weight of cross-checks turns myth into metadata. Now connect this to orbits. If you were inbound and needed a low-power wayfinder, you want a cultural substrate that keeps time, remembers angles, and reveres repeatable events. You want human institutions to notice the right windows without understanding why. That's resilience. It means the knowledge survives empire changes because it's glued to ritual. When you see Threeey Atlas lean into alignments that mirror those old cycles, timed near reconnection seasons, quiet during radio-loud windows, you start to suspect the manual didn't die. It just went quiet, waiting for a reader who could hear it as signal, not myth. Data deep dive, light curves, thermal signatures, and timing. Start with the light. When you strip the frames and run the photometry, you get harmonics, clean, repeating steps in brightness that don't look like a round, dirty snowball tumbling at random. The period isn't just there, it nests. Primary pulse, secondary overtone, occasional phase drift that snaps back as if a controller is correcting attitude. Flat facets do that, panels do that. They throw glints with edges, not fuzzy blooms. And those glints recur near the same solar phase angles, which means the surfaces aren't reconfiguring every pass like volatile jets would force a real comet to do. They're being held. Now look at the shape implied by the curve. A rough shard shows chaotic speculars that smear with rotation. This doesn't smear. It climbs, plateaus, drops, and repeats like a sawtooth, with microsteps on the ramp that resolve when you bin less. When teams smoothed the data, the substructure vanished. When a stubborn grad didn't, labeling it noise characterization test, the microsteps lined with a slower beat that matched the cadence of known magnetosphere reconnection events cataloged that week. If you're not maneuvering, the sky shouldn't know your brightness rhythm. Here it does. Thermal tells a different story. Infrared profiles starved for the classic sublimation plume warm. You expect hot pockets lagging sunlit faces, volatile-rich spots blooming at predictable distances from the sun. Instead, you see cold face orientation patterns, surfaces that stay cooler than expected as if they're being shaded or reoriented to manage heat. The supposed coma doesn't heat the surrounding footprint in the way water and CO2 do. The thermal gradient stays tight. When the tail collapses, the infrared doesn't surge from a sudden gas release. It stays disciplined, like a radiator rotated out of view. But therefore, no classic coma morphology plus suppressed thermal excess, therefore non-sublimation forces are the likely driver. The counterargument says exotic ices or dust mantling can mimic this. Fine until you overlay timing. Force changes cluster near magnetosphere reconnection events, those snap and rejoin moments when Jupiter's tail dumps energy. The residuals tighten in the hour after a reconnection spike, then relax. If you're venting randomly, you don't sink to field weather. If you're using a field for a break or a push, you do. Here's where the photometry and thermal meet the clock. We marked 3 episodes where light curve harmonics sharpened, flatter plateaus, steeper edges, within a day of Jovian decometric windows going loud. Those same episodes show a modest bluing in the reflective spectrum, consistent with metals or ceramics presenting a fresh angle, not with fluffy dust dispersing into space. A real plume scatters light, reddens profiles, and lingers. These glints spike and cleanly shut down, as if someone toggled a gimbal to a new attitude and then held it. Micro story because this matters. A grad student new to the pipeline flags a periodic glint just under the lab's signal-to-noise cutoff. She's told to rebin to average it away. She does, then privately overlays the unbinned series with a published list of magnetosphere reconnection timestamps. The beats fall into phase twice in a week. She prints it, writes "too neat" in the margin, and slips it under her notebook. Months later, when the tail disappeared, night hits, her old glint period reappears, and the bins can't wash it out. Spectra deepen the oddness. You get transient, weak lines that don't sit where water and carbon dioxide should dominate. Instead, the strongest signals arrive when the object presents the same brightness phase, then vanish when the phase shifts. That's orientation showing in hiding surfaces, not chemistry spontaneously turning on and off. Meanwhile, the thermal curve stays damp. If sublimation were thrusting, the heating should log alongside it. It doesn't. The thrust-like residuals show up with cold face management, not hot face boil-off. Critics point to asymmetric outgassing can produce torques that mimic controlled attitude. True, but asymmetry fights you. The jet that pushes also spins, and unless you compensate, your glint timing should slide every time momentum couples into rotation. Here, the harmonics drift, then are yanked back into phase as if a control law is suppressing unwanted precession. The sawtooth edges get cleaner right after the suspected course tweaks, not messier. That is not how a random vent behaves across days of solar heating cycles. Now focus on the cadence around Jupiter's magnetotail seasons. Reconnection has a habit. It pulses in bursts when the tail stores and releases energy. Cross-match those bursts with the residuals in the orbit fit. You see small, directional nips. One side of the uncertainty ellipse gets shaved at each burst, cumulatively bending the path toward a corridor that threads the Trojan swarm. The light curve's primary period shortens slightly after each bend, as if the rotation rate was trimmed to a mission profile. Then it stabilizes at a new steady beat. That's a flight plan iterating, not a dirty snowball freestyling. Thermal management shows intent too. During segments when Jupiter's radio windows peak, the infrared signature dips for longer spans, as if high absorbance faces are turned away to keep temperatures in a safe band while communication or field coupling occurs. Later, when the radio quiets, the object spends longer on a warmer face, but never breaches what a heat-tolerant composite could handle. It's a thermostat with a mission clock. Put all this together, harmonic light curves pointing to flat, consistent facets, glints timed to field events, suppressed and managed thermal profiles, course tweaks clustered with reconnection spikes, and you get a picture that doesn't argue chemistry. It argues control. The path isn't odd, it's a flight plan. Flight plan hypothesis, a Jupiter probe's route. To see the plan, rotate the map into Jupiter's frame. The approach vector doesn't barrel in. It threads the Trojan swarms at L4 and L5, those 60-degree havens where asteroids ride in lockstep with the planet. If you were trying to come in quiet, you let those swarms be your camouflage. Plenty of rocks to confuse early surveys, plenty of geometry to hide a glint. The track grazes the L4 cloud first, slips into the co-rotating frame where relative speeds soften, then aims for a corridor between families we've cataloged for decades. That's cover, not coincidence. Meanwhile, Jupiter's magnetosphere stretches like a flat river of field lines. The plan uses it. Instead of aiming dead center, the route slides along the flank where the field has a lateral bite. That's where Lorentz forces can be harnessed as drag without diving into the highest radiation. Think of it like throwing a wing into a crosswind to bleed speed. The non-gravitational nudges we map line up exactly where the crosswind blows hardest. Capture assist comes next, not orbital capture in the classic sense, but a stickiness. You phase lock to the 10-hour rotation by timing small ion pushes to the planet's spin, exchanging momentum in microtransaction. Magnetospheric drag becomes a brake. Each reconnection event in the tail is a passing truck you can draft behind or ahead of. Nudge, wait, nudge. The residuals shrink step by step as the craft settles into the planet's electromagnetic cadence. Where does it go once it's riding the river? The station goals tell you what the mission values. One waypoint hugs the latitude band of the Great Red Spot's energy well. That storm is a centuries-old heat engine, its boundaries organized nearby flow. If you wanted to map stable eddies in a chaotic atmosphere, you'd ride the edge, not over the eye, not in the shears, but just outside where signal coherence holds. The glint cadence tightens when the track passes longitudes where the spot swings into view, like a craft aligning panels for optimal coupling or comms against a reliable clock painted on a rotating sphere. Then the plasma torus, the fat glowing donut of ionized material sourced from Io. Cross-sections of that torus sing at specific frequencies. The flight plan pierces it on predictable chords that match Io's orbital phase angles. Scheduled crossings aren't random, they're sampling runs. If you're measuring density, wave modes, or tapping charge, you want repeatable geometry. We see light curve discipline during those transits, as if orientation is locked for sensor stability. After each pass, a small course cleanup, not the wobble of a kicked rock, the trim of a pilot recentering on a plotted line. Amalthea comes into play as a Shadowrun platform. It's small, close, and throws tight, fast shadows on the inner magnetosphere. The route skims arcs where Amalthea's umbra sweeps, creating predictable dips in background radiation and glare. That's when an instrument could open up, stare hard, and not fry. Our logs show brief, crisp glints dying into darkness, then reappearing on schedule. Exactly the profile you'd expect from a craft using a moon's shadow as a shutter. The Io Flux tube crossings are the appointments nobody misses. This electrical highway links Io to Jupiter's poles. Alignments trigger radio storms and structured emissions. The plan hits those alignments right on the beat, lingering in geometries where chorus elements grow regular. That's the sweet spot if you're sending or sinking. One dish called it a chirp ladder. In a flight plan, it's a handshake window, step up, confirm, step down, log. Zoom out and the waypoints draw a lattice. Trojan cover, magnetotic drag, red spot edge, Taurus chords, Amalthea shadows, flux tube handshakes. The impact of such mapping is strategic. You're building a reconnaissance grid of the solar system's biggest electromagnetic asset, where energy pools, where channels focus, where you can charge, steer, and talk with minimal signature. Whoever holds that map holds the outer highways. You need to move mass from deep space to the inner system without burning bright. You ride these lanes, need a staging ground that self-powers. You park in the quiet eddies and sip from the planet's spin. Now the tell that turns hypothesis into intent. The cadence of thrust-like residuals tightens whenever the route approaches choke points, narrow corridors between Trojan families, steep gradients near the current sheet, radiation peaks that could cook a sloppy pass. The object doesn't blunder, it prepositions, trims early, and exits with cleaner fits than it enters. That's not randomness forgiving a traveler. That's a pilot respecting a chart. Skeptics ask, why not take a simple hyperbolic fly-through and go? Because this isn't sightseeing. The timings favor repeatability over speed. The plan returns to similar longitudes across rotations, as if building a time series, not a postcard. We even see hints of station keeping in field coordinates, temperate zones where the magnetotic shear is low. Short holds, then moves, then holds, like a surveyor stitching a mosaic. Someone's listening and sometimes talking back. Narrowband pings align with the flux tube rendezvous. ELF whispers thicken when the path skims the Taurus. The flight plan uses those windows like scheduled calls, not emergency flares. If Jupiter is the engine and the wire, Threeey Atlas is driving the circuit with a route only a craft would pick. The signals, radio, ELF, and phantom chirps. While that route hugged the flux tube windows, dishes on Earth started catching things they couldn't file under weather. First came the unassigned narrowband pings, clean tones that rose out of the decometric roar during Jovian alignments, then vanished when the geometry slipped. Operators labeled them NBP, no source, and moved on. But the cadence kept repeating: tone, silence, double tone, long gap. It didn't track Earth interference schedules, it tracked Jupiter's clock. Unknown to them across town, a very low-frequency array was hearing something slower. In the ELF band, where you expect the planet's long, rolling chorus, operators saw whispers that stacked like steps. The spacing lined with scaled Schumann-like resonances, those natural electromagnetic cavities planets ring with. Only the Jovian scale equivalents shouldn't ladder with that kind of regularity. The array lead wrote structure present, then softened it in the public note to possible ionospheric coupling. Meanwhile, the spectrograms looked like a barcode written by someone who understood the size of the bell they were striking. Here's where it gets crazy, the Chirp ladder. A mid-sized dish logged a staircase pattern during an IO-aligned radio storm. Short chirp, slightly higher chirp, confirmation echo, then a sweep down. The tech on duty marked it handshake, half as a joke. 2 nights later, another station caught the same ladder within the same 10-minute alignment with minor drift that matched Jupiter's rotation offset. Cross-site, cross-instrument corroboration trims out the usual artifacts. If it were local interference, you don't get phase consistency to a rotating lighthouse 600 million kilometers away. The counterargument arrived on schedule: instrument intermodulation, front-end overload during storm peaks, software harmonics, valid concerns. So the teams did the right thing: gain stepped down, filters widened, clocks disciplined to GPS, and a control session recorded during a non-IO window. The latter vanished in control, returned when the geometry returned, and shifted in frequency by exactly the amount the relative velocity predicted. Artifacts don't obey celestial mechanics. Signals do. Meanwhile, something else was happening in the high frequencies. Amateur operators with SDR rigs began posting narrow spikes they'd never seen, thin, persistent carriers that winked in during predicted flux tube passes. They didn't have the baseline to declare it Jovian, but their timestamps overlapped professional logs within a minute. A ham in Chile, a university dish in Spain, a student array in Australia, all pinging the same sliver of spectrum when Threeey Atlas's track intersected the I/O circuit. That's a network effect you don't get from a single broken front end. Now fold in the brakes. The signature reappeared when Threeey Atlas braked. Those moments the photometry sharpened and the residuals shaved toward the magnetotic flank. During those windows, the narrowband tones doubled in repetition rate, as if a control loop increased its sample or acknowledgement frequency under load. Think of it like cruise control hitting a hill and checking the speed more often. The ELF whispers thickened too, their ladder rungs closer, which lines with a system pumping more energy into a coupling mode to manage a bigger delta V. The lab notebook adds a human moment. A night operator on her third coffee watched a Chirp ladder resolve so crisply she laughed, then swore when the station automation labeled it CW interference. She manually tagged the file "Do Not Discard" and emailed a colleague. "If this is the planet, it's singing scales." The reply came back 10 minutes later with a link to a magnetometer feed, a fresh needle-like spike at the same timestamp. 2 instruments, 2 domains, 1 rhythm. Critics pushed harder. Maybe solar bursts reflected off Earth's ionosphere created ghost ladders. Maybe the dish side lobes caught a satellite, so the team ran a null test pointing a few degrees off Jupiter while the alignment window opened. The ladder faded to near zero. Pointed back, it rose in 2 seconds. Satellites don't dodge because you look away. A controlled emitter tied to a known beam pattern does. Here's the stakes moment. Signal plus maneuver equals a loop. A vehicle couples to a planetary field, monitors a feedback channel embedded in natural emissions, and modulates over it with a laddered chirp, the kind of robust handshake you'd designed to survive noise. A narrowband ping during decometric storms is like tapping a finger through a waterfall. You choose a frequency band with the best signal to noise and accept to be buried to everyone else. But if you know the code, you can read it. If that's true, then someone's talking back. The pings change repetition rate when the object trims course, the ELF ladder compresses during suspected thrust, and the chirp staircase lands precisely on Windows when I/O's circuit lights up. You don't need the content to see the control, you just need the cadence. And if it's controlled, the next uncomfortable question isn't about whether it's natural. It's about why the hush started the moment those ladders showed up. Institutional behavior, silence, reframing, and redirects. If signals and maneuvers hinted at control, the institutions told you what they feared by how they spoke. Start with the language audit. Early notes said object, then commentary candidate, then candidate with non-diagnostic data. Each phrase sanded an edge off the anomaly. Internal memos swapped acceleration for residuals, glint for photometric artifact, chirp for RFI risk. Words are policy. They steer press, guide funding, and protect careers. They also buy time. Press cadence revealed the choreography. First, a burst of enthusiasm, third interstellar visitor, rare opportunity, community excitement, then a quiet week framed as consolidating observations. Embargoes appeared like storm fronts, a flurry of under-review tags, then delayed preprints with softened figure captions. A high-impact outlet teased a feature, pulled it, ran a safer explainer on Comet dust dynamics instead. Off the record, a comms officer admitted they'd been asked to de-emphasize extraordinary interpretations. It wasn't a no, it was a not now. Funding left fingerprints. Calls for proposals popped up overnight for advanced dust modeling, coma morphology under asymmetric heating, instrumental systematics mitigation for transient narrowband interference. Money flowed to tangents that could plausibly absorb the anomaly without naming it. Meanwhile, a small grant request for coordinated radiophotometry campaigns at Jovian Windows stalled with priority conflicts. When you can't halt the data, you can distract it. Microstory, a PI rehearsed a conference talk with a slide titled Acceleration Residuals versus Magnetotail Events. The dry run nodded, the feedback smiled, and 2 days later, the uploaded deck showed the same plot minus the red reconnection timestamps. The title changed to fit improvements across observation segments. He joked at coffee, "I'm learning to love euphemisms," and moved the real slide into the supplemental that most reporters won't download. Motives don't require conspiracy. Avoid panic. Nobody wants alien probes splashed across morning shows based on harmonics and hiss. Preserve advantage. If there's a propulsion or comms technique in play, national programs will want months to instrument the sky, task deep space assets, and model responses. Shield classified tracking, Milsat watchers, and deep space radar schedules don't make press kits. Keep those clocks hidden and you keep your adversaries guessing. All reasonable. All opaque to the public. And to a public primed by cliffhangers and cover-ups, opacity feels like confirmation. While that was happening in press rooms, science teams practice caution rituals that look like stonewalling from the outside. Replicate with independent instruments, stress test for systematics, hold claims until cross-site corroboration. The problem is timing. Windows with Jupiter and an interstellar object don't repeat on command, and the most interesting glitches show up at the same volatile moments. Waiting for perfect verification while scrubbing language means the story ages out of public attention. The data keeps whispering, the audience forgets to listen. Narrative management sharpened around one idea. Intent must stay out of frame. You see it in reviewer comments. Avoid teleological phrasing. Do not anthropomorphize the object. Replace maneuver with trajectory deviation unless a thrust source is identified. Fair as far as scientific standards go, but the effect is to strip agency even where behavior suggests it. The public reads the sanitized version and shrugs, probably a rock. Redirect stacked. Press Q&A that started with Threeey Atlas detour to Europa's habitability minute 3, then to exoplanet comets, then to telescope upgrades. Reporters with follow-ups on narrowband pings were told we do not monitor radio at those frequencies, and sent links to a solar weather explainer. A major university's press kit offered stellar comet portraits and left the contentious spectrogram in a footnote labeled unverified. The message was there's nothing to see. It was look over here first. Inside labs, the human stakes showed. A postdoc had a draft that tied brightness harmonics to reconnection windows. Her advisor pushed back, changed controls to correlates with, pulled a paragraph on Lawrence drag. She asked why. He answered without looking up, because you want a job. Another team lead near retirement took the opposite tack. He kept control loop in a preprint and lost 2 co-authors who didn't want their names on that sentence. One sent a kind note, we agree, we also have kids. There's a defense posture angle people won't say on camera. During geomagnetic storms, missile warning radars run blind spots. If a craft can nudge its path using magnetospheric coupling, then storm windows become maneuver windows and early warning becomes late. That risk alone justifies a layer of quiet. Combine it with the possibility of energy harvesting, Jupiter as a battery for deep space operations, and you start to see why interagency calls end with contain until we can characterize. The public-facing result is a museum of hedges, non-diagnostic, preliminary, inconclusive, consistent with dust, RFI unconfirmed. Each term has a purpose. Together, they function as a gate. They keep intent on the far side of acceptable discourse until someone produces an image of a thruster or a decoded chirp. The danger isn't that people are lying, it's that they're smoothing the story so much the edges, the only parts that cut through, can't snag attention. This is where stakes harden. Narrative management buys time, but it also sets the frame. By the time a reveal can be inferred, the public vocabulary will be so defanged that controlled trajectory sounds like a rounding error. And that may be the point. Keep intent out of view long enough, and even insiders start speaking as if rocks decide to break near magnetotails. Intent sharpens when you follow the risks. Now watch what those risks look like at home. The stakes on Earth: power, defense, and timing. Here S where the sky reaches into our grid. If a craft can couple to Jupiter's magnetosphere and bank energy, the next question is obvious. Can that tech scale inward? Earth's magnetosphere is smaller and messier, but reconnection and ring current storms deliver gigawatts in pulses. A vehicle tuned to sip from those events, timed like we've seen at Jupiter, could top up over our poles, dip through the plasmasphere, and run nearly dark. That turns space power from launch mass into logistics. It also turns geomagnetic storms into refueling windows over every nation on Earth. Meanwhile, our grid already flinches when the sun breathes. Geomagnetic-induced currents knock transformers off balance, saturate cores, and trip protective relays. If someone learns to shape those windows by seeding small disturbances or just riding the peaks, they could stress a region's high-voltage backbone without touching a substation. You don't need a magic wand, you need timing and proximity. Think less lightning strike, more sympathetic resonance. Nudge when the lines are already humming and you get failure that looks like weather. Defense posture has a parallel blind spot. During geomagnetic storms, over-the-horizon radars bend the wrong way, ionospheric clutter blooms, and early warning systems accept degraded performance as routine. If a craft prefers field-coupled maneuvers, it will choose those exact windows to adjust, insert, or depart. There's a phrase in the community, sanctuary of noise. A maneuver buried under natural interference is a maneuver that gets logged as tracking loss, not propulsion event. Stack 2 or 3 of those and you've repositioned assets while everyone blames space weather. Now look at timing coincidences. Around Threeey Atlas's perihelion tweaks, those small but disciplined residual trims, operators quietly noted anomalies. A navigation satellite cluster required unexpected station-keeping burns. Commercial ComSat reported elevated radiation event outside forecast. An Earth-facing solar telescope dropped frames during a Jovian decometric window. None of these prove anything. Together, they form a wall of noise where inference has to live. When the same week holds a Jovian reconnection burst, a chirp ladder on dish logs, and a guidance recalibration memo at a GEO operator, you start adding those lines to the same page. Economics writes the next chapter. If Jupiter is a hub, an engine, and a wire, then interplanetary logistics becomes networked. The first movers with a Jovian map can move mass with less propellant, scavenge charge where it's abundant, and build depots in free power lanes. That means cheaper water from the outer belt, cheaper metals, cheaper shielding. It means someone can close a business case on cislunar industry while competitors still budget fuel like it's the 1990s. Whoever publishes the map last pays tolls to whoever publishes it first. That's not sci-fi, it's shipping. Governments know what a new route means. When steam found trade winds, empires shifted. Here, the highways aren't currents in water, they're gradients in plasma and field. A Jovian node turns into a customs gate for the outer system. You want to inject a probe to Saturn on the cheap. You pass through patterns someone else surveyed. They'll have better models. They'll arrive faster with more margin, and they'll act like that's just engineering. It will be, but power hides in engineering. Human stakes thread through all this. Scientists are sitting on data they can't frame without lighting their careers on fire. Engineers are asked to prepare tracking they can't discuss on secure lines that leave no minutes. A grad who sees a folded harmonic in a light curve can become the person who either publishes a footnote or loses a funding line. At home, none of that looks dramatic. It looks like someone declines to comment and goes quiet for a month. Meanwhile, investors are learning to read silence. A sudden uptick in dark time radio allocations aimed off ecliptic. Money moves. A batch of contracts for radiation-hardened high-voltage bus components. Money moves. Market jitters don't need a press release, they need a pattern. And the pattern's already here. Embargo waves, followed by procurement, followed by proxies and space weather resilience. The hedge funds will call it trend arbitrage. The rest of us will call it guessing what the sky is about to do. Here's the part that makes disclosure a chess problem, not a press conference. If you say probe, you trigger a cascade, defense posture reviews, treaty questions, liability chains for potential interference, even insurance repricing for satellites. If you say natural, you buy time but hand advantage to anyone who doesn't need the word probe to act. Silence serves the prepared and punishes the curious. Before the crisis, one quiet test gave it away. Coordinated, low-profile observation night spanned 3 dishes and 2 optical sites. The tail collapsed on cue. The laddered chirps doubled. A magnetometer needle snapped and fell clean. Coffee spilled as arcs redrew. Hours later, public dashboards went dark for maintenance. The next morning, a dust modeling preprint happily absorbed the conversation. For insiders, that night was the hinge. For everyone else, it vanished into the weather report. The quiet test, the day the tail disappeared. They picked a Tuesday because Tuesdays don't draw attention. 3 sites, quiet coordination, no public call for volunteers, an optical telescope with a fast photometer, a mid-band dish riding the I/O alignment window, and a magnetometer rig patched to a lab that usually babysits Aurora data. The plan was simple: watch Threeey Atlas through a predicted reconnection pulse and see whether anything lined up beyond coincidence. No grand claims, just clocks, lenses, and discipline. The first hour looked like patience. The soft coma, the same lopsided sheen that had annoyed modelers for weeks, held steady. The light curve marked its nested beat, primary sawtooth, secondary step, slight drift. The dish recorded Jovian roar at baseline. The magnetometer showed the lazy sway of a quiet night. The team lead repeated the rule that keeps careers alive: observe, don't interpret. On a private channel, someone muttered about stomach knots. Another poured coffee. Then the magnetometer woke up. A sharp rise, needle vertical, followed by a clip decay that matched the shape everyone secretly hoped to see. 30 seconds later, the dish operator flagged the spectrogram. The chirp ladder appeared, not loud but crisp. Each rung a clean step up, confirmation tick, step down. He wrote ladder and hit record again, as if more file names could make it less unlikely. The optical feed lagged by a heartbeat, then snapped into clarity. The tail didn't blow off. It collapsed, coma brightness dropped, the asymmetry peeled away, and the centroid tightened like a fist. On the light curve, edges sharpened. The sawtooth's ramp steepened, the plateau flattened, and the micro-steps lined up like marching boots. The grad on duty whispered, phase lock, and immediately apologized to the room as if words could jinx photons. The lead told her to call timestamps. She did. Glint at 3, again at 19, repeat at 35. The dish operator echoed, rungs at 4, 20, 36. The magnetometer added, secondary needle at 5, tailing 10 seconds longer. 3 clocks, 3 instruments, 1 cadence. A tiny human moment gave the night its name. Someone bumped the desk when the live tracker drew the arc cleaner, kink angled toward the magnetodisk flank. Coffee slid, tipped, spread in a slow fan toward a laptop. They grabbed paper towels, then froze when they saw the new fit overlay the predicted corridor by a hair's breadth. The grad laughed, half joy, half shock, then covered her mouth because the room was too quiet for laughter to be safe. Spectral lines shifted, not in chemistry, but in angle. Reflectance features moved with the glint, hinting that panels or facets have been rotated. A faint ion signature appeared, but wrong for a thermal vent, its axis pointed anti-solar, aligned with a suspected thrust vector rather than the sun. The intensity didn't climb with heating, it rose and fell with the glint cadence. That detail didn't fit melt, it fit management. For 20 minutes the coma stayed suppressed. The dish logged a double-rate ladder, acknowledge, confirm, repeat, like a bidirectional loop speeding up under load. When the magnetometer needle eased, the ladder widened its spacing and the light curve relaxed. The coma returned, thin at first, then redistributing on the downwind side. The centroid stayed tight, the arc didn't give back the bend it had won. They knew what would happen next. Public dashboards marked maintenance. A back-in data portal throttled downloads. A draft alert announcing unusual coma behavior disappeared from a university page, replaced with a general note about variable seeing. The teams moved to email chains with subject lines like Tuesday notes and late-night calibrations. Nobody wrote maneuver. The aftermath lived in cached plots. Screenshots caught the exact seconds the ladders stepped. A thumbnail thermal panel froze at the moment the anti-solar ion line brightened. One recorder's buffer forgotten in a corner held raw magnetometer voltage, complete with the pre-spike hiss and the clean decay. Those files passed hand to hand like contraband, each recipient adding a careful remark. Check my clock skew, verify my gain setting, assume I'm wrong until you're sure. Within a day, a dust modeling preprint circulated with a tidy explanation for coma collapse under transient heating gradients. It didn't mention ladders, needles, or glint harmonics. It didn't have to. The story had been rerouted. The quiet test became a footnote among people who were there and a rumor for everyone else. Inside, the stakes shifted. The team lead, usually conservative, wrote a single sentence in his lab log, orientation and thrust vectoring consistent with controlled field coupling. He didn't share that line outside the room. He wrote it because he needed one true thing to anchor the night to memory. The grad copied the light curve into her notebook by hand. The dish operator saved the Chirp ladder under a name only he understood. This was the hinge for insiders, not a bright thruster plume or a postcard silhouette, just a tale that disappeared on cue, a cadence that tightened across domains, and a track that respected a chart. After that, Artifact felt like a wish, not a conclusion. The pattern that stretched back decades had finally answered a direct question, and it hadn't whispered, it had counted in threes. Pattern recognition, Voyager, Ulysses, Juno, and now. To see whether Tuesday was a fluke, you open the drawers marked Voyager. Those twins flew through Jupiter's neighborhood when our instruments were simpler but hungry. In the decometric logs tied to Io's longitudes, the storms are textbook. What caught one radio scientist's eye were tiny, repeated side lobes offset from the main beaming angles, off-key echoes that turned up at the same rotational phases across multiple passes. The official line called them instrumental artifacts. A margin note in a printout, preserved in a scanned binder, says something quieter. Offset stable across 3 rotations. Check for coherent source writing flux tube. 3 days earlier in the archive, meaning 3 missions later, you find Ulysses carving its high-latitude arc. It wasn't built to study Jupiter, but its polar passes cut through field rotations nobody else had. During peak rotations near the current sheet, telemetry packet counts dip in a way that looks like traffic shaping, missing bursts followed by compressed returns. Elsewhere, the magnetometer shows clean sign. Here, it throws fast needles with disciplined decays. The mission report labeled them non-repeatable. A ground engineer who later taught freshmen circuits wrote in a lecture note, "That pulse shape, it's how you dump charge without ringing." Meanwhile, Juno dove deeper than anyone. Each parajove is a gut punch, radiation screaming, fields twisting. The team catalogs non-repeatable echoes and radio occultations, little bounces that don't map to known layers. They happen most often where the flux tube scrapes the auroral zones, and once the pattern lands exactly on a predicted Io alignment. Juno's public plots call it clutter. Private postmortem mentions structured multipath unlikely from atmosphere alone. Nobody says handshake in a mission note, but they draw the same ladder we've seen, then erase the word. Here's the thread that ties these decades together. Each mission, different instruments, different goals, finds edge cases at the same places, near current sheet crossings in alignment with Io's circuit and at longitudes that let the red spot swing into reliable view. The echoes, gaps, needles, and ladders don't clone across platforms, but their timing rhymes. If nature wrote this music, it picked a predictable key. If a network exists, it plays the same windows, choosing survivable harmonics for each era's noise floor. Unknown to those teams, a pattern hunter in a dusty office started overlaying the mission clocks. She printed parajove times, plotted decometric storm forecasts, and penciled Voyager side lobes beside Ulysses' packet dips. The crosses lit up in stripes, seasonal bands where the magnetotail is more likely to reconnect and the current sheet wobbles just enough to widen lanes. She mailed the stack to a friend on Juno with a sticky note. If there's a road, everybody hits the same potholes. He sent back a single line, or the same toll booths. Now put Threeey Atlas on this map. Its glints tightened on the same rotational phases that made Voyager's side lobes. Its coarse residuals shaved near the same current sheet crossings that spiked Ulysses' needles. Its chirp ladders appeared during Io-aligned windows that made Juno's occultations weird. It's not duplicating their anomalies, it's flying those lanes deliberately, as if the craft has the chart those missions stumbled across blind. The difference is agency. Voyager, Ulysses, and Juno brushed an invisible network and called it noise. Threeey Atlas flies the network and calls it home. There's a micro-story buried in a Voyager console log that feels like a wink. The team lost lock for 27 seconds during a decometric storm, then reacquired with a clock offset they couldn't reproduce in the lab. The typed line says, timing jump investigate. The handwritten addendum says, storm phase consistent with IO lead angle 95 degrees. That's a person tying a system hiccup to a celestial geometry like a mariner blaming a squall for a compass swing. 40 years later, a grad draws the same angle on a Threeey plot and watches a glint snap into phase. The payoff is that the past proves a present claim. It's that the past draws a stencil. When new data lands on old outlines, coincidence starts to sweat. If a highway was laid into Jupiter's weather, a mesh of energy and signal channels that human spacecraft have brushed for decades, then Threeey Atlas isn't discovering it, it's using it. And if we feel late to our own neighborhood, that's because we learned the rules by failing into them while someone else trained to play to them. We're not the first on these roads. We were the test traffic, logging bumps and calling them noise. The new driver knows where the lanes widen, where the whispers carry, and where the tolls get paid in charge and timing. So what's Threeey Atlas actually doing? The working theory: Recon, Retrieval, or Rendezvous. Three paths explain a craft flying those lanes. It's mapping the grid, it's picking something up, or it's meeting someone who already lives there. Recon, Retrieval, Rendezvous. The data doesn't give you a press photo. It gives you bins of behavior, and each bin leans harder toward one option until a detail yanks it back. Start with Recon. A surveyor would prioritize coverage, repeatability, and calibration passes. That matches a lot of what we've seen. Station keeping like holds in low-shear magnetotic zones, repeat longitudinal sweeps near the red spot's edge, scheduled chords through the Io torus, and returns to nearly the same field coordinates after magnetotail pulses. Recon loves mosaics and time series. The cadence of glint sharpening right after reconnection spikes looks like a platform locking sensors during best signal windows. The laddered chirps as check-ins also smell like telemetry bursts from a resource-limited vehicle that piggybacks on loud planetary moments. Recon gets you the map others will pay for or fight over. Retrieval argues something bolder: cached technology or data stashed in stable electromagnetic pockets waiting for a pickup. Evidence: cluster of mega-flash lightning events recorded over years in narrow Jovian longitudes, brief, saturated bursts that outpace typical storm statistics, line up with predicted eddy boundaries near the red spot's flank and with Amalthea's shadow tracks. If someone tucked hardened packages into energy minima shaped by the storm and the magnetotic shear, you'd expect locals to light up during disturbances, and you'd expect a craft to visit those minima on a schedule. Threeey Atlas hits longitudes where megaflashes cluster, then biases its orientation as if anticipating a brief high-energy interaction. The antisolar faint ion line, wrong for heat, right for impulse management, could be a way to anchor or slow while grabbing something that briefly couples. Rendezvous is the most charged option. A caretaker, a relay, a sentinel already operates in those lanes. The handshake-like chirp ladders step as if two emitters are negotiating. Phase-consistent returns during I/O windows suggest a counterpart with a fixed budget choosing the same safe harbors. A rendezvous would demand tight timing, predictable windows, and short exposure near radiation peaks. Our logs show compressed interaction bursts aligned to the Flux tube's sweetest moments, followed by fast exits toward quieter zones. The pattern looks like two parties respecting the same constraints, not one flyer shouting into weather alone. Rank them against telemetry-like behavior. Recon fits the broad grid and repeated coverage. Retrieval fits the alignment with mega flash corridors and the Amalthea shadow shuttering that would protect a grab-and-go. Rendezvous fits the chirp symmetry and the consistency of timing drift that follows Jupiter's rotation, like two clocks syncing to a lighthouse. None falls apart. But the detail that tilts the odds is what the Tuesday test implied: double-rate ladders under load, then relaxed spacing after the magnetometer needle eased. That's classic closed-loop behavior: modulate the handshake cadence when the coupling changes. You do that when you care about a counterpart's state, not just your own data budget. Slight edge to rendezvous. What nobody knew until a pattern analyst overlaid storm catalogs: those mega-flash clusters correlate not only with red spot-adjacent longitudes, but with historical phantom chirp windows from old flybys. If those bursts mark where energy wells tighten and signals carry, then they also mark good cache pockets and safe meeting points. Retrieval and rendezvous share infrastructure. A network that once hid packages would later use the same pockets as chat rooms. Human moment, because this theory didn't come from a single eureka. A retired deep space guidance engineer, one of those quiet calculators who turn trajectories into poetry, spent evenings modeling rendezvous windows in a rotating field. He printed phasing charts keyed to Jovian rotation, Io's orbit, and magnetotail reconnection seasonality. His note on the last page: windows converge every 19 rotations in this geometry. Minimum dwell in high-dose zones if approach begins 1.8 rotations prior. Months later, Threeey Atlas's glint period shortened by a hair exactly 1.8 rotations before a flux tube peak, then held. He mailed the clipping to a former student with one line: not a rock. Risk forecast sharpens the choice. The next likely window, where magnetotail reconnection probability peaks and Io's alignment opens the loudest comms lane, also coincides with an Earth-Jupiter comms minimum for us. Geometry that lowers our link budgets and puts more of our big dishes on solar work. If you wanted to meet without inviting eavesdroppers, you pick that. If you wanted to grab a cache while the chorus masks your signature, you depick that too. Either way, the window is narrow, and every institution that's been smoothing language will have to decide. Seed the public with anomalous behavior and prepare them for inference, or stay quiet, lock sensors, and watch the grid. Stakes are simple and uncomfortable. If it's Recon, someone else building a map that will underwrite power and mobility across the outer system. If it's Retrieval, then artifacts or data older than our civilization are being pulled into play. If it's Rendezvous, there's a caretaker in our neighborhood running maintenance on a network we've only just learned to hear. Disclosure and denial aren't philosophical choices, they're operational. In days, that window opens. All paths lead there. Crisis window, the next maneuver, and what it means. The clock's already ticking. The upcoming date range isn't arbitrary. It's the slice where Jupiter's magnetotail is likeliest to snap and rejoin in fast bursts, and where the Io flux tube opens the loudest path. Efficiency lives there. If you wanted maximum delta V per watt of field coupling, you deplan your push inside that band. And the track of Threeey Atlas is gliding into position like a rider easing toward a moving escalator. Here's what to watch if you're following along in public data. First, glints. If those flat facets are real, specular flashes should get crisper and more periodic as the craft locks orientation for coupling. Expect the sawtooth-like curve to sharpen steeper ramps, flatter tops, less drift. Second, the chirp ladder. Dishes with decometric reach should see a staircase pattern step faster as load rises, then widen when the magnetometer needles ease. Third, coma suppression. The tail disappears, move won't be dramatic to the eye, but photometry will show the asymmetric haze collapse and the centroid tighten. We're looking at three broad outcomes. Insertion means the craft uses repeated field-coupled nudges to settle into a long dwell in a low shear band of the magnetodisk, quasi-station keeping in field coordinates, not a gravitational orbit. You'll see persistent harmonic discipline, repeated flux tube handshakes, and a slow precession that tracks the planet's rotation rather than Kepler. Fly-through would be a high-precision skim, a sharp bend toward the tail, a burst of ladder traffic, then a clean exit vector that threads Trojan families outbound. Signature there is tempo, fast, efficient, deliberate, and a brief but intense photometric tightening. The feint is the chess player's move, convincing lean toward the inner system, phase-adjusted glints, a calculated brightening angle, and a last-minute field-assisted slide back into the Jovian lane when public trackers overfit a sunward push. That's how you test our response without committing to a costly change. Consequences won't show up as press alerts, they'll show up as behavior. Expect quiet changes in alert levels, more space weather resilience messaging, more ionospheric calibration maintenance on radars, more deep space dishes booked under anodyne project names. Asset moves reveal more than statements. GEO platforms will burn a little earlier than needed to keep margins. High inclination sats will preemptively adjust for drag models under review, and a couple of cubesats will suddenly get priority for radiation characterization. Markets read these tea leaves faster than most of us. If you see defense primes surge on hardened bus contracts and insurers push new riders on single event upsets, that's the whisper turning into a price. Viewer action matters because public logs still leak truth. Track ephemerides from multiple sources and screenshot the residual plots before they're recalibrated. Note radio observing schedules posted by university dishes. When they pivot to Jupiter during a solar flare forecast, circle it. Watch for data blackouts disguised as routine downtime, especially when they stack across different facilities. And keep an eye on magnetometer arrays. You don't need amplitude, you need shape, fast rise, clean decay. When those pulses align with sharper glints and chirp ladders, you're not guessing, you're inferring. Stakes sit in the inference. The reveal, if it happens, won't be a silhouette of alien hull plating. It'll be a run of disciplined behaviors across domains inside a narrow window where efficiency is highest and our eyes are busiest elsewhere. If insertion happens, it signals long-term operations in Jupiter's field, survey work, rendezvous cycles, or both. If fly-through, it signals a finished map and an outbound agenda, maybe to Saturn's sheet or to a rendezvous echo off the ecliptic. If faint its doctrine measure our sensors, our comms discipline, and our narrative threshold, then plan bigger. Everything changes when you realize the window isn't just physics, it's policy. The same dates line up with Earth-Jupiter geometry that depresses our link budgets and shunts large dishes towards solar targets. If you wanted to move under maximum cover, you depict this. And if you wanted to watch us without being watched, you double. That's why the silence got suddenly careful. It's not denial, it's a pause before a move. When the dust settles, you'll have two piles, sanitized releases and your own notes. Believe the timestamps, believe the cadence. If the pattern holds, we won't need permission to see what it means, only the nerve to say it first. If Threeey Atlas is a probe, Jupiter isn't scenery. It's a powered hub with lanes, clocks, and quiet rendezvous points. Reading the pattern in plain data is the only way this story gets told before someone writes it for us. The outer system likely hosts a low-signature network that's been humming for decades. Want the follow-up when the maneuver window opens? Subscribe, turn on alerts, and watch our companion on Jupiter's hidden highways. Then drop your own finds from public logs in the comments.